Okay, number one, simple or basic integral here. We add 1 to the exponent, divide by the exponent. So we have the integral of x to the fourth, which would give us x to the fifth over 5, plus integral of x give us x squared over 2, and don't forget your plus c. Number two, we need to do some algebra before we can do calculus. And so this integral will be the same as x minus 5 squared, which is x squared minus 10x plus 25, times the cube root of x, which is written as x to the 1/3. It's in the denominator, so we want x to the negative 1/3. Now we distribute the x to the 1/3, so we have the integral of x to the 5/3 minus 10x to the 2/3 plus 25x to the negative 1/3. And notice we still have not integrated yet. So now we add 1 to our exponent and divide. So we have x to the 8/3 over 8/3 minus 10x to the 5/3 over 5/3 plus 25x to the 2/3 over 2/3 plus c. So we just rewrite to get our final answer. We multiply by the reciprocal of the denominator, so we get 3/8 x to the 5/3 minus, we multiply the 3 by the 10, that gives us 30, divided by 5 gives us 6, x to the, to the 5/3. The previous exponent should have been 8/3. Plus, and again, we multiply the 3 by the 25, so we get 75 over 2 x to the 2/3 plus c. Okay, number 3, start by rewriting our square root as a fractional exponent. So we've got x to the 1/2 times x to the 1/3 minus 2x to the 4/5. So when we multiply with like bases, we add the exponents. So 1/2 plus 1/3 is 5/6 minus 2x. 1/2 plus 4/5 would give us, well, 4/5 is like 8/10, and 1/2 is like 5/10. So 8 and 5 make 13/10. And so we add 1 to our exponent and divide. So we have x to the 11/6 over 11/6 minus 2x. Adding 1 to the exponent, we get 23/10 over 23/10. Plus c. And so we can write our final answer by the reciprocal of the denominator, so 6/11 x to the 11/6 minus 10 times 2 is 20, so 20 over 23 x to the 23/10 plus c. The next one we've got x to the n, where n is a constant. So before we can do any calculus, we need to do algebra. So when we FOIL out x to the n minus 2 squared, we actually get x to the 2n minus 4x to the n plus 4. And so now adding 1 to the exponent. N is a variable, but it's representing a constant. And so we just follow our integration rule here. So adding 1 to the exponent, we get x to the 2n plus 1 divided by 2n plus 1 minus 4x to the n plus 1 over n plus 1 plus 4x plus c. So we have 2/3 x to the negative 6 plus x to the negative 2nd dx. So we start by adding 1 to the exponent, so 2/3 x to the negative 5th over negative 5 plus x to the negative 1st over negative 1. I'm integrating, so I don't want my integral symbol here anymore. Plus c. So we have 2 over 15x to the 5th, and it's negative because of the negative 5, minus 1 over x plus c. And we can rewrite our root here as x to the k over r. So we add 1 to the exponent, we get 4x to the k over r plus 1 over k over r plus 1. Now it's bad form to have a fraction within a fraction, so to get rid of the fraction in the denominator, we just multiply by r over r, which is just this fancy value of 1. And so we get 4xr, I'm sorry, 4, we'll write rx, so I can write the exponent after. So 4rx to the power of k over r plus 1 over, and when we multiply the denominator, we have to be sure we distribute. So r times k over r leaves us with k, and r times 1 leaves us with 1. So we have k plus r. Number 7, we're given the derivative as for the functions. That means we need to integrate. Integrate 3 cosine of theta d theta. So the integral of cosine is sine. So we have sine of theta. But we have this constant of 3, so it's going to stay put. So 3 sine of theta plus c. We're given derivative, we want the function, so we integrate 1 plus cotan squared of m. Now at this point we need to use one of our Pythagorean identities. So I start off these problems by writing down sine squared x plus cosine squared x equals 1. And I think which one would give me cotangent? Well, cotangent is cosine over sine. So I divide everything by sine squared x. So by dividing by sine squared x, that's going to give me a cotangent. So we get 1 plus cotan squared x is equal to 1 over sine is the same as cosecant squared x. And so this is the same as the integral of cosecant squared x dx, or in this case it's m. And so the integral of cosecant squared is negative cotangent m plus c. Write the antiderivative of cotan 2x over sine of 2x. So antiderivative of cotangent of 2x over sine of 2x dx. Now this takes a little bit of calculus magic, I suppose. So notice cotangent of 2x divided by sine of 2x is the same as cotangent of 2x times 1 over sine of 2x dx. And notice 1 over sine of 2x is also known as cosecant of 2x. And so we have cotangent 2x, cosecant 2x. So we have the integral of cosecant 2x cotan 2x, which is almost one of our rules, but we got to worry about this 2x. So the derivative of 2x would be 2, so I need another 2 here, but I can't just multiply by 2. I also have to multiply by 1/2. And so now we can treat this as the integral of cosecant cotan, which is cosecant. So we have 1/2 cosecant of 2x plus c. Okay, so let's start this problem off by rewriting it as x to the 1/2 plus secant squared of 3x. Now keep in mind we can integrate each part separately, so x to the 1/2 is a fairly straightforward integral. We get x to the 3/2 times 2/3. Right, so it's like over 3/2, we can just write the reciprocal. Now for the secant squared, we're missing something. We need the derivative of the 3x. So we need to multiply by 3. Okay? But we can't just multiply by 3, we also have to multiply by 1/3. And so we end up with plus 1/3. The integral of secant squared of something is tangent of that something plus c. The next problem at first looks a little tricky, so we just got to start off by doing what we know, which is rewriting it as a fractional exponent. And we have x negative first in the denominator, which is the same as times x. Now notice that the derivative of this inside would be 4x. Well, we're almost at 4x. We need to multiply by 4 and by 1/4. And so we can rewrite this as 1/4 times the integral of 4x times 2x squared plus 1 to the 1/2. And so again, we've got the derivative of our inside. There's our u prime. Here's our u, so we can treat this like u to the 1/2. And so we have 1/4 times u to the 3/2. But it's not really u. It's 2x squared plus 1 to the 3/2 over 3/2 plus c. And so when we divide by 3/2, it's the same as multiplying by 2/3. So we get 2 over 12. But I don't want to write that. I'd much rather write 1/6. So 1/6 times 2x squared plus 1 to the 3/2 plus c. Okay. This problem, we see other tangent and cosine problems, so we tried the same trick as before. So tangent of 2 theta times 1 over cosine of 2 theta. Well, 1 over cosine of 2 theta is the same as secant. And so we actually have secant theta tan theta. And the integral of secant theta tan theta is simply secant theta, except that it's not theta, it's 2 theta. So we need to be careful because we're missing the derivative. We're missing the 2 and the 1/2. And so our integral, because we want the derivative of the inside, needs to be right there. So we multiply by the reciprocal as well. So we get 1/2 times secant of 2 theta plus c. Next, find f of x when f prime of x equals cosecant squared and f of pi over 2 equals 4. So again, we want to integrate our derivative. So f of x is equal to the integral of cosecant squared x dx. Integral of cosecant squared is negative cotan x plus c. And so we're actually given a value, so we want f of pi over 2, which equals negative cotangent of pi over 2 plus c, which is equal to 4. Now, cotangent of pi over 2 is the reciprocal of tangent. Tangent of pi over 2 is undefined, so cotangent of pi over 2 is 0. So 0 plus c equals 4, and so c is actually just 4. And so our function f of x is equal to negative cotan x plus 4. Okay, on number 14, we're given the second derivative and some information. To find the first derivative, we integrate. So we'll integrate x plus cosine of 3x dx. So that's going to give us f prime of x. So I'm going to keep track of what we're doing here. And so the first derivative will be x squared over 2 plus, and the integral of cosine would be sine of 3x. And again, we're missing something here. We're missing the derivative inside, so we multiply by 3 and by 1/3. So the 3 is part of the derivative, so our 1/3 stays put. So we have 1/3 sine of 3x plus c. We're told f prime of pi over 3 equals 4, so we want f prime of pi over 3, which would be pi over 3 squared over 2 plus 1/3 sine of pi over 3 times pi over 3 plus c is equals 0. Now 3 pi over 3 is pi. Sine of pi is, this all goes to 0. And so 1/3 times 0 is 0. And so we simply have pi squared over 9 times 2. So pi squared over 18. Again, that's because when we multiply pi over 3, when we square that, we get pi. So pi over 3 squared is the same as pi squared over 9. If we divide that by 2, that's the same as times 1/2. And so we get 18. So pi squared over 18 plus c equals 0. So our first c must be negative pi squared over 18. So our first derivative function is a half of x squared plus 1/3 sine of 3x minus pi squared over 18. And so we want to integrate that. So f of x, let me get red, f of x will be the integral of 1/2 x squared plus 1/3 sine of 3x minus pi squared over 18. And so integrating, we get x cubed over 6 plus. Now again, we're looking for the derivative of 3x there. 1/3 is there. Okay, so we have to multiply by 3 again, but we also have to multiply again by 1/3. And so that 1/3, these two are going to get multiplied, and this 3 is that derivative. So we're going to have 1/9. Now the integral of sine is negative cosine, so we want minus 1/9 cosine of 3x. And a quick check tells me I'm okay. So the derivative of 3x times 1/9. I multiply this by this, I get that 1/3. All right, so that's a quick check. Okay. And then minus pi squared over 18x plus c. Now this is again f of x. Now we're told f of 0, which notice f of 0, we'd have 0 over 6 minus 1/9 times cosine of 0, which would give us negative 1/9 times 1 minus, well, pi squared over 18 times 0 is just 0. So plus c, this needs to equal 1. So by adding 1/9 to both sides, we see that c is 10/9. And so our function, which is our final answer, f of x will be x cubed over 6 minus 1/9 cosine of 3x minus pi squared over 18x plus 10/9. And finally, number 15, which is a similar problem, but this time instead of being given the derivative, we're just given two function values. So I'm going to start by identifying that f prime of x will be the integral of 1 times 2x plus 1 to the negative 1/2. Okay. So I need the derivative of my inside, which would be 2. Can't just multiply by 2, I also have to multiply by 1/2. And so f prime of x would be 1/2 times 2x plus 1. If we add 1 to negative 1/2, we get positive 1/2. This is over 1/2 plus c. And again, I don't know a derivative, I just know the function, so I'm going to call this c1. Now notice that 1/2 divided by 1/2 is 1. So f of x is the integral of 2x plus 1 to the 1/2 plus c1 dx. And so f of x, again, we're missing the derivative of the inside, which would be 2. So we have to multiply by 1/2. So we get 1/2 times 2x plus 1 to the 3/2 over 3/2 plus c1x plus c2. So just simplifying where we can, 1/2 divided by 3/2 gives us 1/3 times 2x plus 1 to the 3/2 plus c1x plus c2. And so we look at our initial values. So f of 0 and f of 1. F of 0, by plugging in 0 for x, we get 1/3 times 1 to the 3/2 plus c1 times 0, which would be 0, plus c2 is equal 4, which means that c2, if we just subtract 1/3 from both sides, must equal 11/3. Okay. We're also told f of 1. So f of 1, if we plug in, we get 1/3 times 3 to the 3 halves plus 3c1 plus c2, which we already know is 11/3. And this is equal to. So we have 3 to the 3 halves, which is the square root of 27, which doesn't help us a whole lot. So I'm just going to leave it as 3 times 3 to the 1/2. Think about why I would do that. And this is 1/3 times that, plus 3c1 plus 11/3 equals 2. Now, the reason I chose to write 3 to the 3 halves is 3 times 3 to 1/2 is because 1/3 times 3 gives me 1. And so I know I've got the square root of 3 plus 3c1 plus 11/3 equals 2. So solving for c1, I get 2 minus 11/3, which would be negative 2 is like 6/3, so negative 5/3. And I subtract the square root of 3, and I divide by 3. And so c1 is equal to negative 5/9 minus square root of 3 over 3. Okay, so c2 is an easy number, c1 not so easy. So let's go back to our equation here, back to our function f of x. And let's write our final answer. So f of x equals 1/3 times 2x plus 1 to the 3 halves plus, now c1 was a pretty weird quantity, so I'm going to put it in parentheses, so negative 5/9 minus square root of 3 over 3 x plus c2, which wasn't quite as scary, it was still a little unusual, 11/3. Now, if you're wondering, do you have to do all this simplification over here without a calculator? The answer is not really. I would actually accept this answer. You need to be able to solve for c, though. I'm not as concerned with you even simplifying this so much, just isolating the c. So, and then finally, a velocity problem. We're given a velocity and a position, so let's find acceleration. So we call acceleration is the derivative of velocity, which would give us 2t plus 21t squared. And what's a position function? A position function is the integral of velocity, which would be the integral of t squared plus 7t cubed, which gives us t cubed over 3 plus 7t to the 4th over 4 plus c. Now we're given an initial condition. We're told t is 1, position is 11. So that means s of 1 equals 11. So notice this is still s of t. So s of 1 is 1/3 plus 7/4 plus c, and is equal 11. So again, at this point, I'd honestly be okay with you saying 11 minus 1/3 minus 7/4. I would accept that. I'm going to simplify it. Common denominator would be 12. And so this is like 4/12. This is like 21/12. And this is like, let's see, 11 times 11 is 121. So add on under 11, we get 132. So 132 minus 4 is 128, minus 21. So we get 107 over 12. And so our function, our velocity, our position function, s of t, would be 1/3 t cubed plus 7/4 t to the 4th plus 107 over 12. Hope you found the review somewhat helpful. Good luck.